All right, in this video, I'm going to show you guys how to start a new project, get your RAM segment allocated properly, and then analyze the file. I'm also going to show you what happens when you get your RAM segmenting incorrect, or rather just don't set it up at all. It's going to be a denso SH7055. It's going to ask you what language. So you're going to go into Google and type in your microprocessor. Renesys has a nice website. In the manual data sheet for it, it says SH2E. That is the language. I always take the manual and I load it into Google Drive so that I can keep it, and then it also makes it searchable. There is no SH2E, but through quite a bit of Googling, I figured out that SH2A is the proper language. Double click on the file to open it in the disassembly tool. Do not analyze at this point. Go ahead and go to memory map. This is not RAM. This is ROM or EEPROM. Okay, so this is when you open up your data sheet and you find your RAM address. Starts at SHxxx and it ends at SHxxxD. So you add a new segment, block name. This will be RAM, OX, and then SHxxx6000, and then length. Right? It didn't give us a length, so we need to open up our calculator. We go FFFFD was the end address minus SHxxx6000, and that gives us 7 FFF. But hold on a second. This processor holds its I/O, I believe, at the very end after RAM. ROM Raider is a great resource for denso SH processor ECUs, any SH processor ECU, right? So if we look through this article, and I'll put it in the link, but they also came up with 7 FFF, but told us to enter 9 FFF. And I think it's because in this manner, you don't have to type in a new segment of memory allocated specifically to I/O. If you want to go through the trouble to do that, dig through the data sheet, figure out where your I/O is, get it all entered, but absolutely include the total length of everything in RAM if you do not set up a segment specifically for I/O. So we're going to do 9 FFF because I don't want to take the time to set up I/O. Okay, and that gives us FFFE. All right, so ROM is not right. RAM should be read and write. We're going to go with these settings and see what happens here. If we look over in this forum, it states that the first 4 bits of ROM, bytes, are a pointer to where the code starts. So let's go ahead and go into GHIDRA. We're going to go G and then a bunch of zeros and go to beginning of ROM. We're going to click P to create a pointer. Double click on that, hit disassemble. Going to turn that into a function, I guess. I don't know. I have a script that does this stuff. I just figured I'd show you guys digging through the data sheet and setting it up manually. I'll also include the link for the script. Okay, let's go ahead and analyze this thing at this point. We have our RAM set up. We got our start point. We're going to do an auto analyze. All right, so now that it's analyzed, I'm just going to go to a map that I am familiar with. So G, this is my SOI map. Find its reference point. We're going to overlap content with another video that I made showing you guys how to set up structures. And I'm going to show you how this is organized really quick. But definitely go back and watch that other video because I'm sure I include more information on it. This is X, Y, and Z. This is a double word. And this is a float. So this is a structure. This float is the multiplier for map data and or Z. And this is Y length. This is X length. So that's the size of your 3D map. Check out what references it. Okay, and take a look at this. This looks like it decompiled really nicely. These are floats. Okay, in order to get those to actually represent what their value is, you need to go to their data point, turn them into floats. So that one turned to -30 when I found it in the machine code and turned it to a floating point. All right, so take a quick look at this with me real quick, because we're going to show you what happens when you don't set up RAM and you analyze this file. So this is a RAM memory address. This function's sole purpose is to return this value. Okay, let's go ahead and show you guys what it looks like when it disassembles improperly. All right, so we're going to go ahead and delete the RAM, and then we're going to analyze again. I did undo the original analyze. All right, now that we have got rid of RAM and reanalyzed it, don't be confused by this. That's ROM. I don't know why it still looks like that, but whatever. Okay, we're going back to the exact same point. See there? So it doesn't actually let us go to the point, right? We may still be able to name it. Yeah, we can. That's interesting. So we're going to name it IQ or whatever. This one's actually ECT, I think, engine coolant temperature, but regardless. We can't go to that point, so we'll never be able to figure out what writes to it. I am surprised how well it's still disassembled. Sometimes these functions are all messed up and they don't even reference a point. Alright, I think that's going to be about it for this video. Thanks for watching. Check out the other videos. I go into depth on how to use these maps to then track like RPM and injection quantity and torque and whatnot to a RAM address, and then follow that back to different maps to define what those X and Y scalars are on those maps and so on.